Hello everyone and welcome to the next session. So today we're solving the next 5 problems. So I have written down the approach of the earlier problems so that you can check them later on if you want to recall how you solve the problems. So let's quickly jump into the problem. So today's next problem is majority element 2. So let's open that. So we will be given an array of size n and a number k. Find all the elements that appear more than n by k times. So the question is pretty straightforward, so there is nothing much to explain. So if a number is present more than n by k times, then we can say that that number is a majority element. Okay, so how we can do that is, suppose we are given an array like 1 1 2 2 3 5 4 2 2 3 1 1 1. Suppose we are given this number, means we are given this array. So here, and k is, suppose that k is here 4 and total elements are, so total elements are 14, right? So 14 by 4 is equals to 3. 14 by 4 gives us 3. So what are the numbers that are present more than 3 times? So this 1 is 1, so our answer will have 1. Then 2, then 2 is one of our answer. Then anything else? So I don't think there is any number else that's present more than 3 times. So yeah, these two are our answer. Okay, so let me just, so how we will solve this? We will simply take a map. We will use a map and store all of these in our map and keep track of the counter of each elements. So let us just solve that. So I will create a void function. Let's create a void function. Let's call it solve, and it's gonna take an integer array. It will take integer array, then int n, then int k. Okay, these are things that it will take, and let's take one condition. And this condition is that the number should be greater than present more than n by k times. So let's now take one unordered map. It will store the element and its count. Let's call it map. So what I will do here is, now I will iterate over the array. So I will iterate over the array and I will just increase the counter in the map. Okay, so I will just increase the counter. Now what I will do is, I will now iterate over the map. So I will iterate over the map and check if items, so items are the elements that are stored in our map. If items.second, so the second, it gives us the count of an element that's present, and if that element is present more than condition times, then we can simply see out items.first. So that's it. So here we have taken another example. So 1 1 5 2. So here our answer should be 1, then 5, then 2. Let's run it. So you can see that 2 5 1 is our answer, so that's correct. So let me just now write the approach. Here we'll use a map and store the count of each element and check if that count is greater than the condition. Instead of condition, we can write n by k. Okay, so this is our approach. So let's solve the next question now. So max chunk to make array sorted. Let me just open that. So this is our next question. So So the given question is, you are given an integer array of length n represents a permutation of integer in the range 0 to n minus 1. So the elements are in the range 0 to n minus 1. It is important. We split array into some chunks and we will sort them. Then okay, so return the largest number of chunks we can make to sort the array. Okay, so let me just remove this all, and let me just give you one example. So suppose our array was this 0 1 0 2 3 then 4. So suppose this is our array. So in how many chunks we can divide? So we can divide like this. Let's just assume this. Okay, let's take this 3. Like there are now 2 chunks. Okay, so the number of chunks here is 2. One is 1 0 2, and after sorting this we will get 0 1 2, and after sorting this we will get 3 and 4, and after joining both, so we will get this array which is sorted. So here number of chunks is equals to 2, but instead what we can do is we can make chunks like this also. So now total number of chunks is equals to 4, and after sorting it will gives us the same answer. So this is our final answer. So we can make 4 max chunks. So how we can get this answer is, so see, our given input was that in elements will always be in this range 0 to n minus 1. Okay, so 0 to, so we can see here that 1, we got a 1 here, so that it's, so this 1 will impact till the 1th index, right, till the first index. So let me write the index over here. So 0 1 2 3 4. So this one will have an impact till 1 index, then 0 will have impact on 0th index or till 0th index, then 2 will have impact till 2th index, then 3 will have till 3rd index, then 4 will have till 4th index. So what we will do is we will take one major maximum max. Okay, we will take, suppose this to 0 at first. Then what I will do here is, now I will take a answer variable as well. Okay, let's take it to 0 also. So iterate over this. I will iterate over this array. Okay, I will iterate over this array. Then what I will do is I will see that here, and we got 1, right? So it is greater than max, so I will update max by 1. I will update max by 1. Okay, then so let me write the index here. So currently we are at 0th index, so I have updated 1. Then what I will do is I will check if our index is equals to max. Okay, if index is equals to max, then we will increase answer, but here it's not the case. Now we move over here, then we saw that it's 0. So is 0 greater than max? No, it's not. So it will be, max will be same. And again, now we will check whether our index is equals to max. So yeah, we can see that index is equals to max. So we will update answer by 1. Then we moved over here and we saw that max is 2 is greater than max. So we will update 2 with this. Then we will see whether 2 is equals to our index. So yes, we are currently at 2nd index and our maximum is equals to 2. So we will update 2. Similarly, we will move to 3. We see that 3 is greater than max. So let's change max, and we will be in the 3rd index. So change this to 3. So then we will move to 4th index and we will update 3 by 4, means we will update the max value, and we will see that it's equals to the index as well. So we'll update answer by 4. So and this gives us our answer. Okay, so let me just quickly code it. So what I will do is I will take an integer answer, okay, and I will also take one maximum value. So let's suppose it's to 0 at present. We cannot use anything else. We will have to use maximum as equals to 0. So then I will iterate over our array, this array. So I will iterate over this array. Then I will check if array of I is greater than max. If array of I is greater than max, I will simply change max to array of I. I will change max to array of I. Then what I will do is I will check if I is equals to max. If we are at the ith index and that's equals to maximum, then what I will do, I will increase answer by 1. Okay. Then at the end I will return our answer. So this should work fine. Let me run it. So it's working fine. Let me submit it. So yeah, it's working fine. So let us just move to the next question. And before that, let me just write here the approach. So you use use variables using two variable answer initialize to 0 and max initialize to 0. Then iterate over the array and keep updating the max and check if max equals to I, then increase answer by 1, then return answer. So this is our approach. So let us move to the next question. 2. So we will be given similar, it's just like the previous question, but here the only problem is that it's not so that the range will be from 0 to n-1, and also there can be duplicate elements. So this is only the problem. So here you can see that there are duplicate elements also, and also the range is not from 0 to n-1. That's it, and that makes the problem pretty difficult. Okay, so let's just try to understand it with one example. So suppose we are given an array 2, 1, 3, then 4 and 4. So this is our array. So we can make 4 partitions out of it. This is one partition, then this is second partition, third and fourth. So maximum chunks will be equals to 4, and this will be our answer, because after sorting them it will be 1, 2, 3, 4 and 4. So it will be sorted. So maximum answer is our 4. So now our task is how to find the maximum answer. Okay, so for that we will take 2 arrays. We will make 2 arrays. One is left max. Okay, let me just write left here, so it will store the left max, and here right max. So let me just write R. Okay, so both will be of size n+1. If the size is n, then we will make n+1 size of array. So let me just so what I will do is I will iterate this array in this direction once, okay, to store the left values, and in the opposite direction from this direction to store the right values. So at first let's iterate from the left, and we will store the maximum value that we have got till now. Okay, so we are over here. So currently 2 is the maximum, so we will change this to 2. Then we saw that next is 1, but we have our maximum as 2, so we will just simply write 2 over here. And here we saw that it's 3, and it's the maximum that we are currently having. And now we have 4, so this is the maximum, and also next one will be 4. So this is how we will make the left array. And for right array, we will at first initialize the and also here we have taken one, we will have to take one extra, right, because we are making of size n plus 1. So, and we will initialize this with int max values. Okay, so we will initialize it with infinity. So next is we will iterate this array in this direction. Okay, so, and we will store the minimum value that's present. So we will check whether our maximum, so here minimum is infinity, right? We have infinity. So next we got 4, so it is definitely less than infinity, so change this to 4. Next we again got 4, so it will be same. Next we got 3, so this will be changed to 3. Next we got 1, so it will be changed to 1. Next we got 2, but our minimum was 1, right? So we have changed this to 1. So this is how our right array will look like. Okay, now what does this mean is that now what we will check is we will check these two. We will check diagonally, means if we're at the 0th index, then we will be checking with the first index of the right. Okay, so in this similar way we will check this in this way. Okay, we will iterate over this left from 0 to over this index. Okay, so it will be n minus 2 index. So what we will do is we will check if this number is less than this, and we will also take one answer and initialize it to 0 at first. Okay, we will initialize it to 0 at first. So we will check whether this number is less than this number. If yes, we will increase answer. If no, we will not increase the answer. So here we saw that 2 is not less than 1, so we will not increase. Here we can see that 2 is less than 3, so we will increase answer by 1. And here we saw that 3 is less than 4, increase answer by 1. And this is, and here 4 is not, means 4 is less than equals, so if it is also equals, so we will also increase. So here 2, so it was 2 earlier and now it was 3. Then we will check this condition and it's also true, so let's make it to 4, so our answer is 4. So this is how we will get our answer. So why we did this? So that's the important question. So why we check in this way? So what we are storing is, at ith index we are storing the maximum value that can affect our answer, or that can impact our answer. So here the maximum was 2, right? And here over here the minimum value was 1, right? So that's why we checked in this way. Okay, that's why we checked in this way. And here we saw that here the minimum value is 3 and here the maximum is 2. So we can easily just make one chunk between these two. Okay, that was our implementation, and I think it's it's difficult to understand in this way. And so let me just code it. So also instead of using this left max, we can use just one variable. Instead of using array, we can use a variable also. So let me just code it. So what I will do is, at first I will make one array of size, let's right, let me just take it as right. Okay, so and its size will be equals to array.size plus 1. This is the size of the, and what we did here was that we initialize the last index by infinity. So let's quickly do that. So right of array.size will be equals to what? Right of array.size will be equals to int max. Okay, int max. And let's just, n is equals to array.size. Now let's iterate. Okay, so we will be iterating from right to left. right? We will be iterating in this direction from right to left. So for int I will be equals to n minus 1, okay, will be the second last index, means then I greater than equals to 0, then I minus minus. So what we will check here is if our means array of I, if array of I is less than right of I plus 1, okay, if then right of I will be equals to what? Right of I will be equals to array of I, okay, else right of I will be equals to right of I will be equals to right of I plus 1, okay. So that's how we will means make this right array, okay. So we have made this right array. Now our task is to take one integer, means int left, okay, left, and let's initialize it to int min at present, okay, and let's count is equals to 0. So count is basically our answer, so at the end we will be returning count. So now let's iterate from 0. So for int I equals to 0, I less than equals to less than n, then I plus plus, okay. So here we will check if array of I, if array of I is greater than left, if array of I is greater than left, then what we will do, we will just simply change left to array of I, because we will be storing the maximum value in the left, right? We are storing the maximum value in the left, so we will change that. And now we will check if left is less than equals to right of I plus 1, because we will be checking with one index greater. So if that's the case, we will increase count, okay, and at the end we will return count. So I guess this should work fine. Let me submit it. So it's working, so let me submit it. So yeah, it's working, so it's working fine. So let's just move to the next, and before that we have to write over here. So we'll write the approach now. So here we can write that use two arrays of size n plus 1, left and right. So right will store, right array will store the minimum values at index I, and left will store the max value at index I, okay. Then check if left of I is less than equals to right of I plus 1. If yes, cnt plus plus. Okay, so that was the approach. Now next question is max product of 3. So this is the next question, maximum product of 3 numbers. So we will be given an array, find 3 numbers whose product is maximum and return the maximum product. So it is pretty easy question. So we will be given an array, and from that array we will have to find the product of 3 numbers that will be the maximum. But here one thing is that there might be negative numbers as well. So let us see how we will solve this. So suppose we are given an array. any number. So let me just take 1, 2, 3, -4, then -5. So here we can see that the maximum will be equals to -4 into -5, that is 20, then into 3, then multiplies by 3, that is equals to 60. So this will be our answer. So this will be the maximum. So how we will find the maximum? So what we will do here is we will take 5 values: max 1, max 2, max 3, then min 1, then min 2. Okay, so why we took 3 maximums and 2 minimums? That is because if there are 2 minimum numbers, that can be like minus as well. So 2 minimum numbers, after if we multiply them, then they will give us a positive number. So that might help in our answer. But if we take 3 minimum numbers, then that might give us a negative number. So that will not help us in our answer. That's why we took 2 minimum numbers and 3 maximum numbers. So we'll iterate over this and store the values. So at first we found that, so initialize this with, so we'll initialize this with minus infinity. We'll initialize each and everything by minus infinity. Let's initialize this with minus infinity, then this with maximum, that is infinity. Okay, so we found 1. So 1 is greater than m1, so we'll change this to 1, and it's not great. And similarly we won't do anything, and we will check whether if it's less than minimum. So it is less than minimum, so we'll replace this as well, and we won't check for these 2 and this condition. Okay, we won't check for these conditions now. So now we found that 2. Now we are at 2, so we'll see that it's greater than m1, so this will be changed to 2, and m2 will be changed to m1. So earlier m1's value was 1, so it will be changed to 1. And whether 2 is like minimum than 1, no it's not, so we will simply change this to 2. Okay, now we found 3, so we will do what? We'll change this to 3, and we will change this to 2, and maximum 3 will be now storing 1. Now 3 is not less than any one of them, so we won't do anything. So now we are at -4, so it's not greater than m1, it's not greater than m2, it's not greater than m3, but it's less than m1, right? So we will simply change this to -4, and earlier it was 2, so we will change this to 1. Now we see that we are at last index, and here we have -5, so it's not greater than m1, not greater than m2, not greater than m3. So but it's greater than minimum 1, so we will change, means less than minimum 1, so we'll change this to -5, and it will be changed to -4. So now we got our means we have iterated our whole array. Now we will find the values m1 multiplied by m2, then multiplied by m3. Okay, and also another value minimum 1. Okay, this is minimum 1 multiplied by minimum 2, minimum 2 multiplied by maximum 1, and we will find the maximum among them. Among these two, we will find the maximum. We find the maximum, whichever is the maximum, and we will return that answer. So this was the algo. So let us just solve it. So here what I will do is I will take 5 variables. So let's take them quickly. Minimum 1 is equals to int of max. Okay, it will store the maximum value. Then minimum 2 is equals to minimum 1. Okay, then another is maximum 1 will store the int minimum value, and maximum 2 will be equals to maximum 1, then maximum 3 will be equals to maximum 1 as well. Okay, so we have made the variables that we will be using. Then int n equals to nums.size. So then we will iterate over the nums. So equals to 0, I less than n, then I plus plus. So we will iterate over the nums, and we will check if array of means not array. So if nums of I is greater than equals to max 1, if it is greater than equals to max 1, what we will do is we will change max 3 value to max 2, then max 2's value will be changed to max 1. Okay, then max 1 will be equals to nums of I. Okay, if this is not the condition, then else if array of if nums of I is greater than equals to max 2, if this is the case, then what we will do is we will simply make max 3 will be equals to max 2. So else if nums of I, if this is greater than equals to max of 2, then what we will do, if it's greater than max of 2, then max of 3 will be changed to max of 2. Okay, then max of 2 will be equals to nums of I. And another condition is else if nums of I is greater than equals to max 3. If this is the case, then we will simply change max 3, it will be equals to nums of I. Okay, now we have another condition is if nums of I is less than equals to minimum 1. Okay, if it's less than minimum 1, then minimum 2 will be storing minimum 1 value, then minimum 1 will be storing nums of I. Okay, else if another condition is if nums of I is less than equals to minimum 2. If that's the case, we will change minimum 2 will be equals to now nums of I. Okay, so we will, after doing this, we will find all of the values of the variables, and at the end we will be returning maximum of max 1 times max 2 times max 3. Okay, or min 1 times minimum 2 times maximum 1. We'll be returning this. Okay, so I guess this should work fine. Okay, so it's working. Let me submit it. So it's working fine. So now let me write the approach over here. Take 5 variables, max 1 equals to max 2 equals to max 3 equals to int minimum, initialize with int minimum, then minimum 1 equals to minimum 2 equals to int maximum, then iterate over the array and keep on updating the variables. Then at the end return the max of max 1 times max 2 times max 3, or min 1 times minimum 2 times maximum 1. So this was our approach. So now let me just solve another question. So this will be the last question of today. So this is the problem. So largest number at least twice of others. We are given an integer where largest integer is unique. Determine whether the largest element in the array is at least twice as much as other numbers. If it is, return the index of the largest element. Return -1 otherwise. Okay. So we will be given an array and we will need to find the largest number. If so, the condition is the largest number is at least twice as much as every other number. So one approach is that we can sort the whole array, okay, and we can check the last and the second last values, and if the last value is greater than the second, 2 times greater than the second last value, then we can return that number, else we will return -1. Okay, so so that will take of n log n time because we will be sorting the array. So instead of that, what we can do is we can just find two numbers that we'll just find two numbers, okay, and then we will means we will find two maximum numbers out of an array, and we'll check whether the max one is greater than, we'll check whether max 1 is greater than, if max 1 is greater than 2 times of max 2. Okay, we'll check this condition. We'll find, at first we will find max 1 and we'll find max 2, and then we'll check whether max 1 is greater than 2 times max 2. If that's the case, then we will simply return that value, else we will return -1. Okay, so that's pretty simple. So let me just simply code this. Okay, so here I will take max 1 equals to int minimum. It will store the minimum value, right? So then max 2 will be equals to max 1. Okay, max 2 will be equals to max 1. So now what I will do here is then let's take int n is equals to nums of I, nums.size, sorry, not nums of I, so nums.size. Then what I will do is then also what will, so return the index. Oh, it says the index, so let me just take int index. Let's then if by any chance if n is equals to 1, right, if there is only one element, then we will simply return 0. Okay, so now I will iterate over the array. I will iterate over the array and I will be updating if nums of I, if this is greater than equals to, it is greater than equals to max 1. If that's the case, then max 2 will be equals to max 1. Then max 1 will be equals to, it will be equals to nums of I. Nums of I, and since max 1 will be the maximum one, so index will be changed to I. Okay, now another condition is else if nums of I, if nums of I is greater than equals to, if it is greater than equals to max of 2, if that's the case, then we will simply change max of 2 equals to nums of I. Nums of I. Okay, so we will here after this we will find both the values max 1 and max 2. Now we will check if max 1 is greater than or equals to 2 times of max 2. If that's the case, we will return index, else we will return -1. Return -1. Let me submit it. So yeah, so it's working fine. So that's it for today. Let me just write the approach over here. Take two variables, max 1 equals to max 2 equals to int minimum. It will store int minimum. Then we will simply iterate over the array and keep updating, and then we'll keep updating max 1 and max 2. max2, then check if max1 greater than equals to 2 times of max2. If yes, return the index of max1. Okay, so that was the approach. So that's it for today. Thank you and have a nice day ahead.